Okay, here we go. Practice test 1. 9.1 to 9.3. Practice test 1. Here we go. In how many ways can 7 books be arranged on a shelf? 7 factorial. Remember that if you are arranging things in a row, it can be done, well, let's say if you got 8 things in a row, it's 8 factorial. If there's 10 things in a row, it's 10 factorial. If there's 7 books on a shelf, it's 7 factorial. Now, just as a warning, for these practice tests, I am not going to type them into my calculator and get decimal answers. I have given you the answers, so if you want to double check on your own calculator, go ahead, but I'm not going to take up video time to type all this in on the calculator. So I'm just going to do the setups. 7 factorial. Number 2, how many outfits are possible if you have 4 pair of pants and 6 shirts? If you have 4 pair of pants and 6 shirts, and you're going to wear one of each, which I hope you are, then you've got 24 outfits. 4 times 6. In how many ways can you answer 8 true-false questions? All right, now stop and think about this for a minute. There are 8 questions. Here are the 8 questions. How many ways can you answer just the first one? It's a true-false question. So you can answer the first one 2 ways, true or false. How about the second one? 2 ways, 2 ways. All of these have 2 options. Each question has 2 options. Now, when you sit down to take this test, you are going to answer every one of these. So you are going to answer question 1 and 2 and 3 and 4 and 5 and so on. So you are going to have 2 options times 2 options times 2 options, da 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 da. So the answer to the problem is going to be whatever 2 to the 8th is. 2 times 2, 8 times. That's how many ways you can answer the questions. How many ways can I give a pencil, a marker, and an eraser to 3 students in a class of 12? Now, if you have 12 kids and you are giving away 3 prizes, this is either a 12 CP or a 12 C3 or a 12 P3 problem. Which is it? Well, pay attention to what's going on. We're giving away different prizes. And if we're giving away different prizes, then the order that I give them away matters. So this would be a 12 P3 problem. If I were giving away 3 pencils, then it would be 12 C3. We have 12 people, we're choosing 3. The big question is, does order matter or not? In this case, problem number 4, order matters. How many 8-letter words can be formed from the word prettier? Well, with any problem like this, no matter what the word is, you start with however many letters there are. So 1, 2, 3, 4, 5, 6, 7, 8 letters. So you start with 8 factorial. It does not matter if they're repeated or not at this point. Step 1, count up the letters. Now, if any do repeat, we're going to divide by that. They're counted up here, but we're going to divide by that. So I see 2 T's, so I'm going to divide by 2 factorial. I see 2 E's, so I'm going to divide by another 2 factorial. I see 2 R's, so another 2 factorial. And then I'm done with repeated letters. Caution, when you type this into your calculator, make sure you're putting that in parentheses because you're dividing by the whole thing. You want to divide by the entire quantity. Number 6. How many ways can 10 people be seated around a campfire? Well, let's go back to problem 1 for a minute. If these were 10 people seated in a row, it would be 10 factorial. But when we seat people in a circle, or when we arrange in a circle, it's always 1 less factorial because circles have no beginning and no end. So we reduce by 1. So if there are 10 people around a campfire, it would be 9 factorial. If there were 10 people on a log, it would be 10 factorial. But 10 people in a circle is 9 factorial. When you arrange in a circle, it's always 1 less factorial. All right, number 7. I have 10 boys and 8 girls, and I'm going to reach in and grab some. I want 3 boys, so I'm going to start with that. So I have 10 boys, and I'm going to pick 3. Now, that's just like this problem. There are 10, and I am choosing 3. The decision I have to make is it a P problem or a C problem? Well, I'm making a committee. Does the order I pick the boys matter if I'm forming a committee? And the answer is no. You just want to get picked so you can be on the committee. So that's 10C3. There are my boys. Now, the same logic for the girls, only it's 8C5. Now, what am I going to do with these 2 numbers? Well, I am picking boys and girls, so they are going to get multiplied. Number 8, the probability of being dealt a 5-card hand that is all diamonds. Okay, it's a fraction. The denominator is going to be 52C5. I've said it a million times. If the question involves a 5-card hand, your probability is going to be 52C5. Your denominator is going to be 52C5. Now, what about your numerator? Well, we want all diamonds. How many diamonds are in the deck? 13. So my numerator is 13C5. Now, when you type that into your calculator, you are welcome to type it in. The top, write down the answer. The bottom, write down the answer, and leave the fraction. Or you can type in the whole thing at one time, and it will come out as a decimal, which is also fine. Number 9, same kind of problem, only this time we want exactly 3 aces. Now, before we go any farther, I want 3 aces. How many cards are in this hand? It is a 5-card hand. Exactly 3 of them are aces, which means 2 of them are something other than aces. Those 2 cards are not mentioned in the problem, but you must realize they are there because you have to have a 5-card hand. So what do 3 aces look like? 4C3. There are 4 aces in the deck. You're going to pick 3 of them. Now, what about the others? Well, if in the deck 4 cards are aces, 4 total cards are aces in the deck, then there must be 48 cards that aren't aces. That's the jacks and the queens and the 2s and the 3s and all that stuff. There's 48 of those, and you need to pick 2 of them. Now, you want 3 aces and 2 not aces, so we're going to multiply those. It's a probability question, so the whole shebang is divided by 52C5. Number 10 is one of our tree diagrams, because we have one situation depending on the other one. We've got rain and we've got tennis. So one situation depends on the other one. If it rains, my tennis is a certain probability. If it doesn't rain, my tennis is another probability. So I know, because the problem tells me, that it has a 45% chance of raining. And then a 55% chance, I have to figure that out myself, of it not raining. Remember, these 2 have to add up to 1, always. Now, if it rains or if it doesn't rain, I have a chance of playing tennis or no tennis. Remember the little hint I gave you? If you're having a hard time deciding how to set up your tree diagram, remember the bottom row, there are always going to be 2 steps for us. There are always going to be 2 steps. And the bottom row, the second step down here, is always going to be whatever the question is asking. So the question is asking for the probability of playing tennis. So I know tennis is going to be my second tier. So we're going to rain here and tennis here. Now let's fill in the numbers. If it rains, the probability I'll play tennis is 15%. Kids, I'm not making this up and it's not magic. I'm reading the question. If that's a 15, this has to be an 85. Now, if it doesn't rain, the probability I'll play tennis is 90, which means this one would be 0.1. Now, in order to answer the question, which is, what's the probability I'll play tennis, I need this branch, because that's a tennis branch, and I need this branch, because it's a tennis branch. So this one says, it's going to rain, and I'm going to play tennis. So 0.45 times 0.15, 0.0675. It's going to rain, and I'm playing tennis, so I'm going to multiply those. Now, if it doesn't rain and I play tennis, 0.495. So this branch, 0.55 times 0.90, 0.495. Now, it could rain and I play tennis, or it might not rain and I play tennis. Because that's an or, I'm going to take these two numbers and add them together. And that will be the answer to my question. Those two numbers added together. All right, number 11. There are 50 seniors in the chapel. Here's the chapel with 50 seniors in it. All of them enjoy singing or praying. 25 say they like to sing. 32 say they like to pray. The question is, how many enjoy only praying? All right, now wait a second. Look here. There's only 50 kids total, but when I ask who likes to sing and who likes to pray, I got 57 votes. That means 7 kids did both. 7 kids like both. If the whole P circle is 32, but 7 of them are already in the picture, then there must be 25 others who aren't in the picture already. Now they are. If the whole S circle is 25, but 7 of them are already there in the circle, then there must be 18. See these kids right here? These are the 25 that like only praying. They like only praying. Okay. Number 12. Oops, I'm going to need to have some more room here for this one. So before I erase all that, I'm going to go ahead and I'll go in order. So I'm going to erase this now because number 12 is going to take me some space, isn't it? Number 12 says expand, and that's not kidding. Expand, indeed, we're going to expand. We're going to write it out. Okay, so I am expanding x minus 2y to the 4th. So in order to do that, I'm going to need the 4th row of Pascal's triangle, which is 1, 4, 6, 4, 1. There's the 4th row of Pascal's triangle. Next to each of those is going to be an x and a negative 2y. These are separate terms. And in this problem, we need them all because it says do the whole expansion. So we're doing the entire row. The only thing we have missing at this point is our exponents. So I remember that on my first term, my x's, the exponents start with 4 and count down. And then the y's do the same thing, but they go in the other direction. Because every individual term, each of these individual terms, the exponents are going to add up to 4. Now I simplify. Remember that anything to the 0 power is just 1. So this first term is just x to the 4th. Remember that within each term, everything is getting multiplied. It's a multiplication. So I have negative 8 x cubed y. Now in the next term, be careful. I've got my 6, I've got my x squared, but that guy right there is a positive 4y squared. This is a multiplication problem. So I get 24 x squared y squared. That squared applies to the 2, 4y squared. Same thing here. I have a 4, an x, and a negative 8y cubed. Now that is not a subtraction problem. That is a multiplication. So that's going to be negative 32 xy cubed. Anything to the 0 power is 1. So all I have left here is a positive 16 y to the 4th. Positive 16, you took a negative to an even power, so it comes out positive. Positive 16 y to the 4th. The next one, number 13, is almost, well, it's very similar, except you don't have to do the whole row, thank goodness. You only have to do part of the row, a piece of the row. So this time, I would need the 7th row of Pascal's triangle. So here's the 5th row, here's the 6th row, and here's the 7th row. Okay, I don't have that memorized, so I have to figure it out. So there's the 7th row. So if I were doing the entire expansion, I would write down every single one of these numbers just like I wrote down these numbers when I started this problem. But luckily, I don't need to write down the whole row. I'm only interested in the 3rd number. So I'm just going to write down the 21. But next to that 21, I have to put a 2x and a y. Now I need my exponents. If I wrote out the entire row, the first 2x, the first term right here, if I wrote out the whole row, would be 7, and then 6, and then 5. So my exponent here is 5. And I got that by counting. Here the exponent would be 7, 6, 5, 4, 3, 2, 1, 0. If I needed the whole row, but I don't, I only need that one, so 7, 6, 5. Now, if that's a 5, this is going to have to be a 2, because if I'm expanding to the 7th power, my exponents have to add up to 7. So now this is a multiplication problem. I have a 21, I have a 32 x to the 5th, because I have to take 2 to the 5th, and I have a y squared. So again, it's a multiplication problem. So I get 735 x to the 5th y squared as the answer to the question. Now I'm going to calculate HC5 by hand. That's 8 factorial. Start with that number on the top. Then we put this number on the bottom. And then we put the difference of those two on the bottom. So when we calculate this by hand, there's one number on the top. The big number goes on top. And there's 2 numbers on the bottom. That one and that minus that. So then, again, you're doing this by hand. So we're not typing that into our calculator. You are showing me the work. 87654321 divided by 54321 and 321. All times it. Well, those are going to cancel. 321 makes 6, so that's going to cancel with that. And all we have left is 8 times 7, which is 56. So now we've got a situation where we want to find the probability of this and the probability of this. All right, now we know that the probability of the A ball is 0.7 and the probability of the B ball is 0.5, and the probability of A or B is 0.3. Not A or B, A and B, I'm sorry. This says A and B, so this is the probability of A and B. That's what that says, A and B. Now, wait a second. A and B. If you are A and B, you are here. So this is 0.3. A and B. That's the overlap. Now this says the whole A ball is 0.7, which means if 0.3 of it's there, this has to be 0.4 because the whole ball is 0.7. This says the whole B ball is 0.5, so this has got to be 0.2 because the whole thing has to be 0.5. Now if you look at that, you've got 0.4, 0.3, and 0.2. That only adds up to 0.9. This is a probability problem. See all these P's? That's probability. This is a probability problem, and the total probability, that whole box, has to be 100%. In the circles, you've only got 90% represented, so there must be a 0.1 that's outside the circles. So if A is the kids that like M&Ms and B is the kids that like Twix, then these are the kids that don't like either one. So now we're going to answer the questions. This says, problem number 1 right here says, A and not B. So you are in the A circle, but not the B circle. So if you are in A but not B, you would be 0.4. You're right here. You're in the A circle, but you're not in the B circle. This says you're not in A and you're not in B. Well, wait a minute. If you're not in A and you're not in B, that means you're not in a circle, which means you are 0.1. Okay. Now we want both to like math. So we've got class 1, we're picking 2 kids. We're picking 2 kids. We're taking 1 out of class 1 and 1 out of class 2. That tells me I'm going to be multiplying. So A says, both like math. That means your class 1 kid likes math and your class 2 kid likes math. So the answer is 0.6 times 0.4 or 0.24. B says class 1 likes math, so that's 0.6, and times Class 2 likes science, that's 0.2. So the answer is 0.6 times 0.2 or 0.12, 0.12. Neither will like art. So that means the kid I get out of class 1 does not like art. Well, 0.1 likes art, so 0.9 doesn't. So the probability that class 1 does not like art is 0.9. And I want the same thing in class 2, that would be 0.9 again. So that probability is 0.81. Class 1 does not like art, and class 2 does not like art. D. One will like science, and the other one likes English. Now this is trickier because I don't know who's coming from which class. That could be science here and English here, that is class 1 and class 2. Or it could be English here and science here. So I have to do both. All right? So here we go. Science and English. That would be science out of class 1, English out of class 2 would be 0.1 times 0.3, 0.03. Or we could have English out of class 1 and science out of class 2, which would be 0.2 times 0.2 or 0.04. Now we could have that situation, or we could have this situation. So the answer to the question is 0.07, because when I have an or, I add. That's practice test 1. Good job.